Today's video is for Algebra 1, Chapter 3, Lesson 5. But first, a quote from Horseradish by Lemony Snicket, page 45. In most cases, the best strategy for a job interview is to be fairly honest, because the worst thing that can happen is that you won't get the job and will spend the rest of your life foraging for food in the wilderness and seeking shelter underneath a tree or the awning of a bowling alley that has gone out of business. Thank you, Lemony Snicket. All right, on to some math. Compound inequalities are two inequalities that are joined by and or. And means that the answer to the inequality or a solution for the inequality or a value that makes the inequality true has to be true for both of the inequalities. Whereas if the two inequalities are joined by or, the value that makes one of them correct is okay, or the one that makes the other one that is correct is okay, but it doesn't have to be both. If it's both, it's and. If it's only one, it's or. Okay? So, and compound inequalities. Here's one. We have x is greater than or equal to 5 and x is less than or equal to 7. So if I go ahead and put these on a number line, there's a number line, we're going to have x is greater than 5 and x is less than 7. So all of the values that work for this compound inequality have to be between -5 and 7. It can be -5 because it makes both statements true, and it can be 7 because it makes both statements true. But it can't be 8 because of this one, and it can't be -6 because of that one, okay? But anything in between is fair game, okay? So if we were to make a compound inequality for the number 1 here, all real numbers greater than 2 but less than 9. Well, x can be greater than -2, greater than, not equal to, greater than -2, and, because really that's what the but means, but less than 9. So x has to be less than or equal to 9, or less than 9. There we go. So there's the compound inequality based on that statement. All right, number 2, compound inequality. The books were priced between $3.50 and $6 inclusive. So x can be greater than or equal to $3.50, and x can be less than or equal to $6. There we go. All right, so there's a compound inequality. All right, so what happens if they give you one to solve, where you have to figure out what it is? Because these right here are pretty simplified. There you get a little scarier. So let's talk about the little scarier ones. Okay, so here is 2 examples of just, usually what you're going to see. Because they have something going on in the middle, you need to figure out what it possibly can be. Because basically this is just another way to write what's going on. Actually, and I could have written this one in the same way, that one right here, where I say x is less than or equal to 7, but it's also greater than or equal to -5. Okay, so there's that compound inequality, and basically this implies the word and. Okay? All right, so back to the original thing. Okay, so what happens if we have more than a variable in the middle? Let's say we've got 3 times the variable, right? Well, if I'm going to undo what's happening to it, I do need to divide by what's going on. So 3 over 3 is 1, but I also have to divide everything else that's going on here by 3. Okay? So if I divide everything by 3, I get -6 divided by 3, which is -2, is less than or equal to x, which is less than 5/3. Or, let's see here, that's 1 2/3. Okay? And you can always go back and check. Well, what's a number between -2 and 5 2/3? Well, you could pick 0. Well, 3 times 0 is 0, and 0 is definitely greater than -6, and 0 is definitely less than 5. Okay? So this basically describes all the possible values for x that would make that value true. Okay? And again, you can graph it if you want. They'll ask you to graph a few times, but it's pretty easy. You guys should be able to do this by now. That's a solid circle, that's an open circle. So all of the values in here are completely legitimate for that problem. Okay? All right. Next up, All right, we need to take care of lower priority operations first when we are undoing things that happen to the variable, therefore the opposite operation. So I'm going to minus 1 on both sides, and when I mean both sides, because I have a compound inequality, it means all sides. 13 minus 1 is 12, which is greater than or equal to negative 3n, which is greater than 6, because 7 minus 1 is 6. So then, obviously, I need to divide by a negative 3, and you're probably going, Miss Deach, does that mean I need to flip the direction of the inequalities? Yes, it does. So now that I have divided by a negative number, I actually need to flip. So 6 divided by negative 3 is 2. Flip the direction of the inequality. Negative 3 over negative 3 is 1. Flip the direction of the inequality. 12 divided by negative 3 is negative 4. So it actually makes sense now because I'm looking for a number that's greater than negative 4 but less than 2. If the direction of the inequalities hadn't been switched, we would have said negative 2 is less than n, which is less than or equal to negative 4, which doesn't make sense because in this case, in this wrong case, we're implying that negative 4 is greater than negative 2, and that would be wrong. So again, if you don't flip the direction of the inequalities when you multiply or divide on all sides by a negative integer, you're going to have a very bad time. Okay, so you got to make sure you flip the direction. Okay, last slide. We need to talk about ORs. Or no, we're still talking about ANDs. Okay, so normal pool pH must be between an average of 7.2 and 7.8. Write a compound inequality for this situation. Okay, so things that are okay for x, and you guys can actually probably figure this out without doing the example problem, but we're going to have x, which is the average reading of the pool either for that day, and it needs to be between the lowest pH, which is acceptable, and the highest pH, which is acceptable. Okay? All right, somebody just threw a ball at the window. I'm sorry. All right, so there you go. So that's the compound inequality. Now, if you're actually going to use a problem like that one, they give us 2 readings for the day. So if the pool read 7.0 in the morning and 7.9 in the afternoon, we can go ahead and find the average. 7 plus 7.9, that's 14.9, and we got to divide 2 because we've got 2, and I believe that gives me 7.9 something. So 14.9 divided by 2 is 7.45, which, does that fall between here? Why, yes it does, because 7.2 is less than or equal to 7.45, which is less than or equal to 7.8. So yes, it falls within the safety range. It means people can keep swimming. Because if you're not in the good pH range, you can't let people swim. That's your lifeguard lesson for the day. Okay, last slide. The OR, okay? So whatever value you find, as long as it works for 1, it's okay. But the graphs for this one are kind of crazy, so I'm going to make sure I graph this one for you. Okay. So let's go ahead and finish this problem. Now we need to get the variable by itself, so I actually have to simplify both problems. I have to simplify the side on the left side of the OR and the right side of the OR. So I'm going to minus 7, that's negative 2x is greater than negative 4, divide by negative 2, divide by negative 2. I divided by a negative number, so I have to switch the direction of the inequality, and that gives me 2. So basically I'm just simplifying. All right, other one. Add 4, 3x is greater than or equal to 9, divide by 3, x is greater than or equal to 3. So now it is time to graph. So if I go ahead and graph, I've got a number line, that's 0, 1, 2, 3, there's 2, and there's 3. All right, so let's graph the first one. I'm going to graph the first one in red. So x is less than 2. Can't include 2. So x is less than 2. And then I'm going to graph the right one in green. And x is greater than or equal to 3, so it includes 3. And it goes that way. So the solution for these two is either x is less than 2 or x is equal to or greater than 3. And that's the funky inequality I was talking to you about. When you've got OR situations, there's a good chance that the arrows on your graphed solution are going to go in opposite directions, whereas when they're inclusive and they can include the things in the middle, they're going to be heading in the same, opposite direction if it's or. Well, it's technically opposite direction when it's and as well, but they're going to meet in the middle when it's and. When they're or, they're going to go off opposite directions and then never touch. Okay, I'm done. Sorry this wasn't recorded earlier. Bye, guys. Bye.